In this video, we will delve into the intriguing cosmological bodies known as galaxies. We know that the formation of galaxies began shortly after the Big Bang, with gravity gradually drawing matter together. Galaxies began to form in areas rich in dark matter, where immense clouds of gas, of mostly hydrogen and helium, would collapse and rotate. As they began to evolve, star formation began to occur. It is believed that these galaxies most likely formed first, but due to galactical interactions and mergers, many evolved into elliptical galaxies. We now classify galaxies according to the Edwin Hubble classification scheme, where we categorize these galaxies by their appearance into elliptical, spiral, lenticular, and irregular galaxies. Here, in the Coma cluster, we see mostly yellow elliptical galaxies, which are identifiable by their distinct lack of disks and a noticeable fade in all directions from the center. We also see primarily one large blue spiral galaxy, characterized by its spiral arms that extend outwards. We see a similar trend in the Hercules cluster, seeing some yellow to red colored elliptical galaxies and some blue to purple colored spiral galaxies that have an orange bulge at their center. Firstly, we notice that the spiral galaxies are often blue or purple in color. This is because the spiral arms are regions of active star formation. They contain young stars appearing blue due to the high mass density and star formation rate. In contrast, elliptical galaxies appear to have a yellow to red hue, as they contain much older stars, forming as a result of galaxy collision. They have very little dust or cool gas, thus have little to no star formation occurring. The bulge of spiral galaxies are typically more red to yellow in color, indicative of older stars. In contrast, the disk of the galaxy is typically blue, indicating younger, hotter stars and active regions for star formation. Now let's observe a high-resolution image of the galaxy collision NGC6745. Commonly seen to be the shape of a bird's head, we see evidence of recently formed blue stars along the bird's beak and upper area, indicated by its blue hue, brighter and more dense-looking star clusters, and a noticeable cloud of dust and gas. This suggests that as the galaxies interact, they will not only distort the galaxies in shape and gas composition, but this collision will likely lead to more star formations occurring. Now we will gather data from 3 different galaxy clusters and observe how many spiral, elliptical, and irregular galaxies there are from a sample of 20 galaxies. Firstly, we see that the Fornax cluster has 2 noticeable spiral galaxies in pink, and 18 elliptical galaxies in yellow, as shown in the image below. Next, the Pandora cluster. Similarly, it had 4 spiral galaxies and 15 elliptical galaxies, but we also noticed 1 irregular galaxy in blue. Lastly, this is the Spiderweb cluster, and it is slightly different as it is a protocluster, meaning that it is a group of galaxies that is beginning to form a cluster. Thus, this gives us deeper insight into the early universe. In this case, we notice that from the sample, there were 5 spiral galaxies, 8 elliptical galaxies, and 7 irregular galaxies. Now we will compare these clusters to the Hubble Ultra Deep Field image, which reveals thousands of galaxies both near and extremely far away, thus showing galaxies at different stages of their evolution. Here we see 9 spiral galaxies, 6 elliptical galaxies, and 5 irregular galaxies from a sample of 20. Comparing the similarities and differences from this data, we see that all of the galaxies contain a variety of galaxy types, with the Fornax and Pandora cluster having a very high proportion of elliptical galaxies and low proportion of spiral and irregular galaxies, compared to the Spiderweb cluster and Hubble Ultra Deep Field image, which have a more diverse but balanced distribution. This is significant to our understanding of galaxy formation, as it suggests that galaxies which are denser, such as Pandora's cluster, accelerate the transformation of spiral to elliptical galaxies due to high collisions and mergers. The Spiderweb cluster, being a protocluster, gives us deeper insight into the early universe, suggesting that there were more irregular shaped clusters and diversity before galactic interactions transformed these galaxies. Comparing this to the Hubble Ultra Deep Field image, which looks at a broader section of the universe, also captures less dense regions where such galactic interactions do not occur as frequently, thus showing greater diversity in galaxy types. If we could take the Hubble Ultra Deep Field image in 10 billion years' time, we would expect vast differences. For example, many of the irregular or spiral galaxies would evolve into ellipticals due to interactions or mergers. Furthermore, as the expansion of the universe is occurring at an accelerating rate due to dark energy, we would observe galaxies with higher redshift. Ultimately, the rate of star-forming galaxies will decrease due to the expanding universe and the depletion of cold gas that is needed to form stars over time, as more stars are already being formed. In this experiment, I was able to expand what I know about galaxy clusters and different galaxy types, specifically related to their prevalence, spread, and evolution within the universe. Thank you for watching, and this is my student ID card. By Maria Patino, z5420265.